Hey, this is Jordan. I am going to be making a video here on the basics of Simulink, Stateflow, and HLD Coder. So, let's jump right in. First off, we're going to open up MATLAB. I'm using 2017A, as you can see here. Hope it's the same version you're using, otherwise things could be different. From here, we want to jump straight into Simulink. This wonderful little button will get us there. And we're just going to choose a blank model, jump straight in. There are probably shortcuts you can do that will get you here faster, but I'm showing you the bare bones, and hopefully can show you all the different settings we'll need to check to make sure that HLD Coder works. Okay. First things first, let's open up our library. We come down here to Stateflow and add a chart. Drag it on, it'll take a second. Yay, chart. Now I'm going to rename this. I'm going to call this entire thing Blinky Simple, and then I'm going to designate this as the chart for later purposes. So ta-da, here it is. If you'll notice, included underscores instead of spaces. Jordan Luke told me to do this. I'm doing it just to make sure that spaces don't have issues with HLD Coder and when we actually go into compiling this. So, double click to enter into this chart. You'll see the wonderful yellow background to indicate we're in the chart. If you just click and click, we've got our first state. This arrow indicates the entry point, but then it went away because, anyways. So, this is our first state. For a simple blinky on the FPGA, I'm just going to label this state as light off, and I'm going to make it bigger just for me, and then I'm going to add another state, make it about the same size, light on. Now we want this default transition is this entry point, so in case it didn't stay, if you clicked on it soon enough, the entry point would stay, but I'm going to add this entry point, so that's saying as soon as we get into this, we're going to start there. The red border went away because it didn't have a default entry point. So from here, you can just hover over the edge, click, and drag down to the bottom, and click and drag up to the top. Those are our transitions. So we've got our default entry state, we pop in here, and then from here we'll just switch on and off and on and off and on and off. So one setting that you need to make sure you go and check, if you just right click on the background and go to properties, so this is the property of the chart, you need to make sure to click execute enter chart at initialization. Otherwise it'll come up with an error later that will say, hey, you didn't check that, you need to go in and check that. So from here we're going to assume we're going to use a 50 megahertz clock because that's convenient for this demonstration. So come up and click the gear, model configuration parameters. And then in this solver, we want to change this to fixed step, so we have fixed steps all the way through. 50 megahertz, do the calculations or find a calculator for you. You can set this to 2 times 10 to the negative 8, and that will give us 50 megahertz. Now, when we actually simulate it here, it won't look like 50 megahertz because time goes slower in this simulator. Anyways, if we get into this state, after the state name, we hit enter. There are 3 different things you can label inside states in Stateflow. Entry, during, and exit. They're pretty self-explanatory. Entry, the things after entry happen when you enter the state. During the state, do the things. And then exit, when you're right about to leave the state, do those things. So for our case, we're going to say entry, and then we do a colon, So all the things lifted after entry colon will be upon entry. So I'm just going to create a variable light is equal to false. And by using false, then Simulink should know that it's a Boolean and life will be good. And then come down here and do a very similar thing. Entry colon light is equal to true. Semicolon to end it. So this should come in, start at light is off, state, which says the light is off, Boolean false, and then we'll come down here. If we just run it like this, then it'll just keep flipping around and flipping around because we don't have any time constraints. So on these wonderful transitions, if you come over to the question mark, this says, hey, you haven't put up any parameters for this transition. For this simplistic state, we're just going to use after. So because we've set the simulation time to 50 megahertz, if we say after 25, 1, 2, 3, 4, 5, 6 ticks, this says that we'll come into this light off state, and then before we transition to the light on state, we'll go through 25 million ticks, which corresponds to, at the rate of 50 megahertz, half a second. So we'll come in, the light will be off for half a second, then the light will be on for half a second, and then we want to do the same thing here. After 25 tick. So if we take this and we run it, it's going to come up and say, hey, I have issues, because we've instantiated this light variable, but we've never actually assigned it, and the easiest way is just to hit run, and it'll come up and say, this has unresolved symbols. Great. So one of the windows that popped up is this symbol wizard. So this says, it looked at it and said, we think this is an output variable. I say, great, that's exactly what I want it to be. Hit OK. Close out this, and then hit run once more, and now it should be resolved, so it should run just fine. Here at the bottom, you'll see the simulation time, which is going pretty dang slow. T corresponds to seconds in this case, so we're at 1/10 of a second, and this is supposed to happen every half a second. So if we sit here and wait for just a little bit longer, we'll see the transition happen from light off to light on. So for accurate timing, if you want your Simulink seconds to correspond to real seconds, you'll have to fudge things a bit, which I'll do right after this, but we're coming up here on a half a second, at which time this should transition down. Yay, it worked. So if you want to see things go faster, then you can either adjust how fast the simulation runs up here in this wonderful little gear, or for my sake, I'm just going to take this down by a factor of 100, hit play, and we'll see it toggle between the two. Yay! So come back in here, fill this back in just so it's all right and correct. And then we're going to pop one level up. Again, if you remember, we had this in a chart. So it doesn't throw a warning at us. I'm going to come up here and stick in an output block. This would just be a Simulink warning. It wouldn't actually do anything for our HDL code. So I'm going to connect that up because here in the warning, output port of 1, because we said it had an output of variable light. It was unconnected previously, so I'm putting this in so this warning will resolve itself. Now, a thing about HDL Coder is you always want to use HDL Coder on a subsystem. So this is great, but what we actually want to do is we'll want to right-click on our chart and come up here to Subsystems and create subsystems from selection. And then, just for labeling purposes, I'm going to change this to be simple Blinky. Is that what I labeled the other one? Simple Blinky subsystem. Double click on this, Blinky symbol chart. So I'll swap this background. This I'm just doing so when we go into HDL Coder and Libero, you can see where it actually instantiates the subsystem itself and where it instantiates the chart, because we don't actually need in this subsystem this output. We just want this chart, but for HDL Coder to play nicely, then we want to put it in a subsystem. Anyways, from here, I'm just going to save this as video Blinky. Ta-da! And then we should be all set to go. We're going to right click on the subsystem, come down to HDL code and generate HDL for subsystem. If we click on that and then toggle back over to MATLAB, if you give it just a second, it'll start saying, hey, I'm working on it, and it'll come through after it's done and it'll generate a couple of reports and it'll say HDL code generation complete. So it's nice because it says here 0 errors, 0 warnings, 0 messages, but if you want the full report, you can click on it right here and it'll pull up the full report. If errors or things are found, then it'll tell you here and you can catch it before you move it on. So that's the basics. And it also told you where it stored your VHDL files in here, so we will access those when we move on to Libero. That's it for this video.